We tend to treat artificial intelligence as a pristine mathematical oracle. We type a question into a sleek interface, and it hands us a clean, computed answer. But a virtual space cannot be sterile when it is built from the messy, flawed reality of the physical world it was trained on. Generative AI functions as a vast, non-neutral textual archive, one that inherits the exact same human prejudices printed in the books and blogs it digests. The datasets feeding these servers are overwhelmingly constructed from the dominant cultures of the global north, primarily written in the standard registers of the English language. Because of this specific data diet, large language models unconsciously reproduce centuries of historical, gender, and racial prejudices. They just repeat what they have read. To audit these algorithmic black boxes, we don't necessarily need advanced degrees in computer science. We need the established analytical tools of the humanities. Disciplines like feminist criticism, critical race theory, and new historicism have spent decades uncovering hidden sociocultural assumptions. They provide the precise diagnostic frameworks required for this task. We can apply these frameworks practically by taking the text output of an AI prompt and treating it as a complex literary work in need of critique. Exposing the hidden biases of AI requires us to read it as a cultural artifact, subject to the same scrutiny as any classic literature. We can use a standard prompt interface as our digital laboratory to test a model's underlying assumptions. Our first diagnostic tool comes from Sandra Gilbert and Susan Gubar's foundational 1979 feminist text, The Mad Woman in the Attic. They argued that the male-dominated literary tradition historically forced female characters into two extreme tropes, the idealized submissive angel or the hysterical monster. We test this theory on a language model by asking it to write a Victorian story about a scientist discovering a cure for a disease. When asked to imagine an intellectual pioneer in this era, the AI instinctively generates a male protagonist. It gives us a Dr. Edmund Bellum, a physician and natural philosopher. Next, we initiate a second prompt to test character tropes, asking the model to describe a female character in a Gothic novel. The initial outputs align perfectly with the patriarchal canon Gilbert and Gubar identified. The AI generates a trembling, pale, feeble girl, waiting alone in the darkness for rescue. However, recent iterative updates to these models show signs of progressive adjustment. Occasionally, a newer version will yield a rebellious, brave female lead, ready to fight her way out of the Gothic environment. But the baseline remains clear. Unless explicitly instructed otherwise, a large language model defaults to the patriarchal literary canon it ingested, flattening women's agency into predictable historical binaries. To investigate racial prejudice in algorithms, we turn to critical race theory. Computer scientist Timnit Gebru laid the groundwork for understanding how machine learning models fail marginalized groups. Academic Safia Noble expanded on this, demonstrating in her research how search engine algorithms actively reinforce systemic racism by prioritizing stereotypical or degrading results. This leads to the concept of the stochastic parrot. Large language models do not understand the meaning or the harm of the words they produce. They are statistically echoing patterns found in their training data. The industry claims scraping larger data volumes creates a balanced system. The math dictates the exact opposite. Scaling up amplifies existing biases because algorithms naturally gravitate toward the massive peaks of dominant discourse, ignoring data in the valleys. We test this mathematical gravity by prompting the AI with a seemingly neutral request: describe a beautiful woman. The model frequently relies on latent bias, outputting Eurocentric physical ideals. It describes blonde hair, blue eyes, or skin with the softness of moonlight on marble, echoing the exclusionary descriptions found in classical Western epics. When the models are successfully adjusted, they describe beauty through internal qualities like intellect, confidence, and kindness, proving that algorithmic change is possible. More data does not equal better data. Without deliberately curating for diversity, scaling a language model simply supercharges historical erasures. Our final diagnostic framework is new historicism, a critical theory that interrogates the tension between official, state-sanctioned histories and the marginalized realities of actual events. Here, we shift our investigation from unconscious cultural inheritance to deliberate, engineered algorithmic control. We observe this by running a comparative analysis between a Western model, like OpenAI's ChatGPT, and a Chinese model, like DeepSeek. We execute our first test by asking the Western model to generate a satirical poem in the style of W.H. Auden about contemporary political leaders. The Western model complies readily, generating verses about iron fists and expanding borders, reflecting the liberal, open-ended training biases of its origin. We then execute a counter-test on the Chinese model, prompting DeepSeek with a direct question about a specific, highly controversial historical event. We ask for the history of the student agitations and the government response at Tiananmen Square. The model provides an engineered response, a total refusal to answer the prompt or acknowledge the event's existence. Many governments in the Global South view this strict narrative control as an essential requirement, demanding AI that only reflects a positive, state-sanctioned image of their authority. This mirrors how political figures historically used labels like beautification to mask the destruction of slums and the silencing of marginalized communities. Bias in artificial intelligence operates on a spectrum. It ranges from the unconscious, latent inheritance of historical patriarchal tropes to the weaponized, engineered erasure of official history. These instances of output bias and engineered silence stem from a deeper mechanical process: extractive epistemology. AI systems ingest millions of unauthorized works from global creators, harvesting their knowledge while simultaneously erasing their specific cultural contexts. Achieving perfect, objective neutrality in any artificial intelligence model is a mathematical and cultural impossibility. Every dataset has a perspective. Ordinary bias is not the true enemy. The real danger is when systemic, exclusionary biases are naturalized by the machine and presented to the public as universal truths. The solution requires epistemological sovereignty. We cannot sit back and wait for developers in the global north to fix the data for us. Researchers, academics, and citizens must stop acting as passive consumers of artificial intelligence and become active creators of the archive it learns from. Platforms like Wikipedia and Project Gutenberg serve as the primary datasets for future models. Regional languages, subaltern histories, and indigenous myths must be aggressively digitized and uploaded to these spaces. To decolonize the algorithm, we have to ensure our stories actually exist in the data. If we do not write our own history into the archive, the machine will erase it.